Hello again. So we are almost done with this chapter already. We are going to look at chi-squared test of independence today. The good news is that this test is almost exactly like yesterday's test. So in fact, this very first example that we're going to go through, I'm going to try to have you guys do most of the work. So I'm going to be telling you to pause the video quite often, and I want you to actually pause it and do what I ask you to do. Obviously, I'm not sitting there watching you, making sure that you're doing it on your own, but you're only going to learn this if you have a chance to try it yourself and double check with what I'm doing. So I'm going to keep telling you to pause it and work all this out and then push play. So I'm going to have pauses here and there where I'm not talking and I'm making sure that you actually try to work it out. But I should be able to break this lesson into 2 videos. So hopefully this won't take too long. I'm going to jump right in. Chi-squared test of independence. So it says, suppose we are interested in finding out what sports high school students play. In particular, we are interested in finding out if students' current math class has any relationship with the sport they play. We took a random sample of 335 high school students who play one sport. So as you can see, what we have down here is a two-way table, just like yesterday. The biggest difference between yesterday's two-way table and today's two-way table is this right here. If you notice, it says we took a random sample of 335 high school students. We didn't take 2 samples, we took 1 sample. And when we took the 1 sample, all 335 of these students, we asked them 2 questions. What math class are you in? And what sport do you play? So what we did is we recorded 2 pieces of information from the 1 sample we took. That's the biggest difference between an independence test and a homogeneity test. So as you can see, we have our two-way table. We're going to need to have our totals and our expected counts because we're still going to check the observed compared to the expected. So I want you to do that right now. I want you to put in the totals and I want you to find the expected counts. So go ahead and pause my video to do that. Okay, hopefully you have had a chance to come in here and write in all the totals. So if you did the totals, this is what you should have gotten. And then if you did your expected count, remember with baseball, math 2, you would have to do the row total times the column total divided by the grand total. And you'd have to do that for all of them. So I just rounded to 1 decimal, but these would be what your expected counts are. In fact, I'm going to go ahead and label that now, expected counts, so that I can just refer to it later on in the test. Okay, so moving on, I've already talked about the fact that the main difference between an independence test and a homogeneity test is how many samples you took. In this case, we took 1 sample and we gathered 2 pieces of information. So what we're really interested in knowing is, does this show statistically significant relationship between a current math class and sport played? We want to know, is there some kind of relationship? Okay, correlation might be another word that you guys are thinking. Does math class play a part in what sport they play? That's what we're trying to show. So if we're trying to show that depending on what math class you're in, that's going to kind of determine what sport you play, we have to assume the opposite. We have to assume that there's no relationship. So here's how we would write our null and our alternative. Our null hypothesis: there is no association between math class and sports played for high school. So we're basically saying, yeah, they have nothing to do with each other. For the alternative, though, we're trying to show that there is a relationship. So we're saying there is some association between math class and sports played for high school. So I just use the word some, saying, yeah, there just is a little bit. And as usual, we have to have an alpha level. Okay, so there's the state portion. All right. In the plan portion, we again need the name of the test. Now, it's not a homogeneity test because we're not comparing 2 samples. It's a chi-squared test of independence. The reason it's called an independence test is because we want to know if they're independent of each other. So independence, it helps if I could spell it right. All right. So we want to know if these two variables are independent of each other or not. That's why we're doing an independence test. Just like before, we have to do the plan step. So I'm going to give you guys a chance to try the plan step. So press pause and fill it in. Hopefully you have tried it yourself. You should have done the random condition. It's one random sample of 335 high school students. We had to check the 10% condition since we took an SRS. So I'm saying here, assuming 335 is less than 10% of all students who play sports, because we don't actually know what school we took this from. If we took it from Redwood, we actually would not be hitting the 10% condition. So we're just assuming that we have enough people here. So I kind of add in that word when I'm not 100% sure, okay? And then you should have done the expected counts, the large sample size. All expected counts are greater than or equal to 5, and you could say C above. And as you can see, looking at all the expected counts, every single one of them is greater than 5. I have shown that. I have checked it. We are good to go. Now, again, the nice part is the do step is exactly the same as yesterday. We're going to need a picture, we're going to need the formula, you're going to need to add up the components and find the p-value. So go ahead and pause my video and do that. All right, so just double checking real quick. You should have had a skewed distribution, chi-squared. Hopefully you checked the degrees of freedom. Remember, this one's probably the trickiest part for you guys. Hopefully my little box trick is making sense. If I go back up here, now remember, the formula is technically row minus 1 times column minus 1. If I did the formula out, there's 3 rows, 3 minus 1. There's 4 columns, 4 minus 1. So 3 minus 1 is 2, times 4 minus 1 is 3. 2 times 3 is the degrees of freedom of 6. Now to me that's kind of a lot of work. I mean, it's easy work, but what I could do faster is just chop off one column, chop off one row, that's the minus 1 aspect, and count. We have 1, 2, 3, 4, 5, 6 left. So that's the degrees of freedom of 6. So hopefully that's what you guys got down here. We need to find a chi-squared value and find the p-value associated with that chi-squared value. So, chi-squared equals, hopefully you showed your work, observed minus expected squared divided by expected. All you have to do here is show a little bit of work. So, I started with 35 minus 27.8 squared over 27.8. Those are the observed and expected for Math 2 baseball. And then I personally like to head downwards. So I then did 42 minus 38.4 squared divided by 38.4. That's still baseball, but this time it's the Math 3 class. Plus dot, dot, dot. And then I like to just go to the very last one. Basketball pre-calculus would be 21 minus 18.6. Squared divided by 18.6. So hopefully you guys went into your calculator and put all of the observed in list 1, put all the expected into list 2, and then had list 3 calculate the formula for all of these for you, so you didn't actually have to type all of them in. So I've done that already. I wrote all the components down, so these are all of the components, okay? When you add those up, again, a quick trick for adding them is since all of these components are in list 3, in fact, I'll go ahead and just show you on the calculator. Okay, so here's the calculator. I have these all in my calculator. Observed, expected, and then these are the components. Since all of these, see how they're all decimals? You really don't want to just add the ones that you chopped off. Like I only wrote down 2 decimals. We don't want to have too much rounding error. I'd rather add up all of these. So what I did is I hit stat, calculate. I'm using one variable statistics, okay? But I want to do it on list 3 because list 3 has all of those components in there. When I hit enter, it tells you a whole bunch of information about it. But the key piece here is the second one, the sum of x. That's the sum of all the values in that list, which is 28.99. So that would be the chi-squared value. Okay? So 28.99. Hopefully that's the chi-squared value you got, and I'm hoping that you actually did it yourself. So if this is my chi-squared value, 28.99, I hope you plugged that into the chi-squared CDF with 28.99 being the lower bound, the degree or the upper bound being a large number like 999 with the degrees of freedom of 6. Again, make sure you have labeled those. And then you should have gotten a number with e to the negative fifth power, I think it was, or negative fifth power, something like that. It ends up being, if you move the decimal, 0.00006. I think it had an e to the negative fifth. It was 6 point something e to the negative fifth. And that's why we have so many decimals. You got to move the decimal over 1, 2, 3, 4, 5. Okay, so that's how we got the p-value. And I'm going to go ahead and indicate p-value here. So now that I have my p-value and I have my chi-squared value, I want you guys to write a conclusion. So pause my video and write a conclusion just like you've always done. Okay, so hopefully you've tried out the conclusion. Let's double check it. Assuming the null hypothesis is true, there is no association between math class and sport played. There is a 0.00006 probability of obtaining a chi-squared value of 28.99 or higher purely by chance. Because this alpha is small, I'm going to say this provides strong evidence against the null hypothesis and is statistically significant at alpha equals 0.05 because 0.0006 is less than 0.05. Therefore, we reject the null hypothesis and can conclude there is a significant relationship between math class and sport played. Specifically, we notice the number of Math 2 students who play football is much lower than expected. So this last sentence here, this is another way that you could write the follow-up. Because I rejected, I went further and said which one I noticed the biggest difference between Math 2 students who play football. And if we compare, that's actually because of this chi-squared value right here. If you look through there, baseball, 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 volleyball, volleyball, volleyball. This is the first football one, okay? So looking back up here, the football, 1229, the expected was much higher. So we had a much lower number than what we expected to see. And that is the largest component of why we rejected the null hypothesis. Okay? I'm going to go ahead and stop the first video here so that you guys can take a break and then go ahead and move on to my next video for the second side.